Here's a submission from Servod Kat. We have some pitch coupling on high throttle, pitch upwards. That's going to be tricky to get just from your black box, but unless we have a perfectly clear example of where you raise the throttle but don't move the pitch stick, uh, ultimately, I think the way to get that is make sure your P is high enough and then raise your I until it goes away. And if you have to raise your I to a really extreme level to get it to go away, then something else is wrong. It's a trickier problem. I don't know. But if we look right now, you're on LuxFloat. Your pitch I gain is 450. That's not exceptionally high. I could see that going as high as easily 0.6, without even batting an eye. So I would say that probably the way to fix that pitch coupling is to raise your pitch I gain a little more, but just off the top of my head. Oscillation on wide open throttle, that's probably going to be P gain. We'll take a look at your P gains and see if they're about right. And then odd yaw oscillation on the black box logs. That's going to be a tough one as well. I'll take a look and see what I can see. A timestamp would be helpful. Would have been helpful. Now it's too late, but a timestamp on exactly when it's happening would be helpful, unless it's sort of happening all the time. We'll see what we see. Let's get to it. We'll start by looking at your gyros first. I want to point out here, notice that when your throttle is low, you're basically at idle, and there's this kind of thickness to the line that we would normally say was noise. Don't worry about that. When the throttle is low and the motors are idling, the gyro is thicker. Probably, I think it's because the motors are at such a low RPM that the vibration and the harmonics of the vibration and all that stuff is at a lower level than the filter would normally get. So if the filter has a cutoff at 60 hertz and normally your motors are at around 300 to 350 hertz, you're well above the cutoff and your motor noise is well filtered out. But when your motors are idling, maybe they're going much, much slower, maybe around 100 hertz perhaps. And so the noise gets past the filter in a way that it doesn't when you're actually flying. So when you see that you're at zero throttle here and you see this thick noise, just ignore that. That doesn't mean anything. And also, I can almost see that there's a kind of a wave-like surging to it that is probably some a beating of the frequencies as they interact and cancel. If you don't know what beats are, I don't even know how you would begin to look that up, frankly. Harmonic beats maybe would be a thing to look for. It's when two frequencies are close together and they add and subtract to create a second frequency. It's not unlike aliasing, actually, in a way. But anyway, my point is just, if you see this and you're at idle, don't worry about it. That doesn't mean anything. As soon as you get flying, it'll go away. And sure enough, notice as soon as you start flying, those lines thin right out and everything looks great. So your gyros are not a problem. So now as you start flying, what do we see? Well, we can see that D is not overactive because we don't see these huge D spikes. There is some high frequency noise in the D term, which is the sharp up and down, the thin up and down spikes compared to the sort of overall lower frequency waveform. That's not a problem necessarily, and it could certainly be something, if you're not logging at 1-to-1, which many people can't these days, certainly could be something relating from that, who knows. But overall, D looks okay. It's a little sloppy here as you raise the throttle. In fact, if we go to a very high throttle situation, actually it doesn't seem as bad when you're at the highest throttle. See, the D term cleaned up here pretty nicely, whereas somewhere around 15 or 1600, again, this could be some kind of a physical characteristic of your frame where it has a strong harmonic at a certain frequency that you're hitting in this throttle position where the D term gets really sloppy. I don't know if this is something I would necessarily worry about, though. The D term can be a little sloppy and not make problems. And then there's a point where you've crossed a line and, okay, now it's too bad. And you got to kind of know where that point is. But just because I see this, I wouldn't necessarily criticize your tune. Like, I know that your D gains are actually really low. Hang on, right here. Your D gains on roll is 7. That's really nothing. So, I mean, you can't say your D gain is excessive here. It just isn't. So if anything, you might need a little filtering, maybe, but maybe this is fine the way it is. If we look at your P term on roll, I think it looks, if anything, a tiny bit underactive, but maybe not. Like if we look at times like this, like you're clearly flying here at 1300, 1360 throttle, right? You're clearly flying here. You're not just hovering or whatever. And you know, but P-term really isn't doing anything. And it's only if we can find more active spots, we can never really, I think, find any spots that I've seen so far where we really see anything that starts to look like hard oscillations. So if anything, this P-term is a little low, or maybe it's just fine if the copter's flying how you like it. Here it almost starts to get active. We see a motor maxing out here. Now it's a little active, you know, but it could almost come up. So that's what the roll axis looks like to me. We still haven't identified your oscillation on wide open throttle. So let's take a look and see if we can find any examples of your pitch coupling first. And I'm going to look for a place where you raise the throttle, but it's going to have to be a place where you leave the pitch alone mostly and look at the gyro to see if the gyro does anything. And what let's do is let's do a custom graph with RC command pitch and RC command throttle on one and pitch gyro on the other. So here you start to, now you're pitching back. You start to raise the throttle. Throttle is now maxed, I guess. And not much is happening on pitch. So I wouldn't say that we caught an example of this coupling happening here. How about here where you raise the throttle? You raise the throttle. Hard to tell. I mean, that line looks pretty zeroed out here as well. Raise the throttle. Here's a pitch back. RC command is just a little negative here. Not very much. Yeah, I feel like that's a little more pitch back than you commanded. So maybe this is a situation where we got something going on. What I'd like to look at is, I'd like to look at the I term, actually here. I want the I term on pitch and see what it's doing as you raise that throttle. And you can see it goes positive. Yeah. So the gyro goes negative. I feel like we're going to just say that RC command was at 0, even though it was very slightly pitched back. I feel like you didn't get as much, you got more pitch back than you actually commanded. And here's what the I term tells us. Notice that the I term goes positive. So the I term is also saying that there is uncorrected error, and the I term is trying to correct it. The I term is opposing the gyro, which means that the gyro is pitching back more than it's supposed to, and the I term is trying to pick it up. But it doesn't do a good enough job picking it up. And here we finally have mostly picked it up, and then we're on to the next move. So let's break this down, because I do think this is pretty interesting. The fact that the I term rises like this to oppose the gyro movement confirms to us that this is uncommanded motion, and that error is being left behind by the P term. So oftentimes when we compare RC command and the gyro, we say that RC command should roughly track the gyro, but it's hard to tell if RC command, if you command a certain amount of pitch back, well, how much pitch back should there be? Is there too much or not enough? And by watching the I term, you can get a sense of that, because if the I term is close to 0, or if the I term is rising to oppose the move, then we're getting too much. If the I term is descending to work with the move, then we're getting not enough. Okay. Don't focus on whether the I term is 0, because very often in a normal flight condition like here, let's assume that this is forward flight, right? Notice that the I term is positive, and that's normal. The I term is counteracting some kind of aerodynamic effect that's occurring. So the fact that the I term is non-zero, that doesn't mean anything. The baseline for the I term in this flight condition is whatever it is. And what's important is that as we change the flight condition by raising the throttle, the copter pitches back and the I term rises to oppose that. So I term is saying you're pitching back, but you're not supposed to. It's this rise in the I term that is instructive, not necessarily the absolute value of the I term. It's the way the I term changes in response to the gyro as the throttle moves. Okay, so you are in fact getting this pitch back and result of the throttle. Now, what's causing it? I don't know. Throttle and pitch coupling is a weird. I think my personal theory is that it's some kind of an aerodynamic effect that relates to the way that the props, the rear props, are interacting with the prop wash from the front props. I have no scientific evidence to back that up, but it would make sense that if there was an interaction there, then it would be dependent on the speed of the motors. And as the motors sped up, for example, as the motors sped up, the rear motors would be interacting with more prop wash, and therefore let's say that the more prop wash there is, the more the rear motors have to work to get clean air and get thrust. So as you raise the throttle, the rear motors need to spin up more because the front motors are throwing more dirty air their way. Don't put too much stock in this. I just made this theory up. It just sounds good, but it doesn't mean it's right. Okay, if that were the case, then what we would see is that the higher throttle, the faster you're flying, the more positive I term there would be. And as you raise the throttle, you would then need to, the I term would need to climb to compensate. And if it doesn't do that fast enough, you get this pitch back. Okay, so what should you do? Well, let's look at your P term on pitch first, because my philosophy is that you should always solve the problem first with the P gain, if you can. And then when you're sure that P gain is as high as you want it to be and you can't push it anymore, then you start solving the problem with the I term, but not before you make sure that the P term has done all the work it could possibly be doing. And so let's just look, and by the way, I think D is excessive here on pitch. This is more activity than I would like to see on the D term personally. Now, what is your D on pitch is not very high either. It's only 8. Take it down to 5. I know, right? What's the difference between 8 and 5? This feels too active to me personally. And this high throttle oscillation you're hearing, the number one culprit to me looks to be this pitch D term personally so far. Yeah, it's not so bad though when the rest of the time I just happen to catch you at a very high throttle point. I don't know if it needs to come down or maybe filtering or whether you have some kind of. See, here's what I don't get. It looks pretty normal the rest of the time. I take back what I said about taking it down to 6. It looks really normal the rest of the time. It's only when you're at high throttle that it goes crazy. Which kind of makes me wonder if you have a vibration issue that's bringing out the problem in the D term here. Nah, it's pretty active here. That's at mid throttle. It's pretty active. It's just because you knocked your throttle all the way down. No, now it's fine. You're 13, 14, 15. Yeah, something's going on with your copter right around 1500, 1600 throttle where you get this crazy vibration. You've got something mechanical that is coming out right in that throttle range. It feels to me like this is not a tuning. I mean, you could work with the issue with tuning, but the fact that it's happening right in that throttle range makes me wonder if there's something that you should be chasing down in terms of vibrations, something mechanical in terms of vibrations or something being loose. Or, I don't know. Getting back to the question of pitch and pitch throttle coupling, the P term on pitch does not look overactive. So it feels to me like if you want to fix that problem, the first thing to do is to raise your pitch P gain. You're at like 1.1 right now. Maybe take it up to 1.3 or 1.4 and see how that works. At the same time, for now, let's just take your D gains down. Take your D gains down to like 4, okay? And let's make sure that we know that the D term is not messing you up as you try and get your pitch, as you're trying to get your P gains really dialed in. And I can't stress this point enough to anybody who's still listening after now 14 minutes. Take your D gains all the way down to like 3, 4, 5 to a very low level and get as many problems as you can solved with pitch, with P, because especially on the later versions of Betaflight, you know, the D gain is gonna season the soup, but it's not the base, right? You can get a lot of good tuning done with P and I, And if you've got really fundamental problems like pitch throttle coupling, you need to be fixing that with P and I, not with D. And D is only going to confuse the issue while you try and solve it. So it's only after you're sure that your P is almost perfect where you want it to be that you should then start to introduce this chaotic element of D to the equation. Okay, so as far as oscillation on yaw goes, let's have a look. So if we look at your yaw gyro, what if we zoom out on your yaw gyro? Are we going to really even see anything? I mean, I don't know. I mean, you're sort of flying. I don't know. I'm not sure. I'm not really sure I can see what you're referring to. I'm sorry to say. I'm looking now to see how the P term is corresponding to your stick input. So, for example, what we could do is we could take RC command yaw, and we could take P term of yaw, and we could put them on a graph together. Well, that is interesting. For example, here the P term is the RC command is flat, but we can see the P term moving down here. Let's get the gyro in there as well. Oh, I see. It's a subtle little move. So the gyro, the stick is centered, the gyro goes positive, the P term opposes it. That's good. Yeah, that is interesting. There's some activity here. I can't say as anything about this really jumps out at me. Sorry to say. So if I had general advice for you, again, look how sloppy this gets when you raise the throttle. You got something that's getting really sloppy when you raise the throttle. And the thing is that these axes don't look too bad the rest of the time. Maybe yaw P is a little high, but then they look pretty normal, and then they just go bonkers when you raise the throttle right around 15 to 1700 RPM, or 1700 on the throttle. So that makes me think that there's something mechanical, like a dinged prop or a bad motor or something, or maybe even your ESC timing. Sometimes if you have BL Heli and you don't have dither turned up all the way to like 15, there can sometimes be interactions between the ESC and the motors that cause there to be harmonic oscillation, whatever, vibrations at certain throttle positions. I just don't know. It feels to me like what you have here is not a tuning issue, but something mechanical that is occurring at that throttle range, especially that where the whole thing just gets really bad. I don't know what are you just. I would have to try to chase down the mechanical issue if I could. All right, hope that's helpful. Happy flying.